This video will cover the first page of notes on the topic of solving log equations. The first thing that I put up here is for us to remember the exponential form and the logarithmic form. More importantly, we need to remember how we can go from one form to the other. Aside from that, we're also going to be talking about the common log and the natural log. The common log is when we have a base 10. It's so common we just write it down as log. So if you only write down log of x, then we're all going to assume it's the log of base 10 of x. We also have another one that we're going to talk about, which is the natural log. That's when the base is e. E is called the natural number, and it is the value of 2.718, and it goes on forever like pi. We will denote natural log with ln. So when we write down natural log of x or ln x, that just means we're taking the log of base e of x. The reason why we're going to talk about these two logs is that we actually find them in our calculators. So I will show you how to use a calculator and the log buttons as well. For example number 1, we're going to use a calculator to find these values. So the first one we're going to do, remember we could have just written this as log of 1,000. But I want to remind you that the 10 is there because that's going to be our base. And we want to see that it's equal to 3. Now we can quickly check this one. We know our base is 10. We know our exponent is 3. And we know that 10 to the third power is equal to 1,000. But we can also stick this in the calculator. Let me show you that now. For our problem, we will hit the log button, and then we will hit 1,000. It's a good habit to close your parentheses so we know we're taking a log of 1,000. When we push enter, we will see our answer of 3. If we go to part B, it says for us to find the log. So I'm going to clear this, and I'm going to have the log of 142. Close my parentheses and push enter, and we see the value of 2.152. I just rounded it to 3 decimal places. And then the last one is if we want to find the log of 0.00583, close my parentheses and push enter, and we'll find our value of negative 2.234. Remember that our domain for log is 0 to infinity. So if we take a look at that, if I try to take the log of a negative number, we're going to see that we should have an error for that value because it's not in the domain. Now let's do some of the natural log. So I'm doing part D, where it says take the natural log of 1,000, closing my parentheses and pushing enter, and we can see we have 6.9077. So when I round it, it becomes 6.9088. So let's do part E. Part E says let's take the natural log of 142, close my parentheses and push enter, and we see that that's 4.9558. If I round it, it's 4.956. And now for the last one, let's take the natural log of 0.005832, and we have a negative 5.144. So I just wanted to make sure that you understood how you can use a calculator. Even though you may use a calculator to find approximate values, I will always be asking for exact values, in which you do not need a graphing calculator. Another big thing I wanted you to see was that even though we were taking the logs and natural logs of the same number, our answers were different because the bases were different. Now let's go to example number 2 and try to solve without a calculator. That just means we're going to have to use some exponents. So let's go through example A, where it says log of base 5 of x is equal to 2. Let's rewrite it as an exponent. The base is 5. Our exponent will be of 2, and that will equal to x. So we can see that this is our problem, and we can solve that because x is equal to 25. If we had our exponent is x, so notice we have 3 is our base, our exponent is x, and that's equal to 81. We can see that problem right here. Well, if I can get them to be the same base, remember 81 is 3 to the 4th, and if I have the same base, then the exponents have to be the same. So we get x must equal to 4. And the last case that you might see is when x is actually part of the base. So in this case, we have our base of x to the exponent of 2, and that's equal to 1/4. So that means I would have x squared is equal to 1/4. When we're solving, we're going to take the square root of both sides. Remember, most of the time we think about plus or minus. We will not in this case because we know that our base has to be positive. So we're just going to take the principal square root of both sides. The square root of x squared is x, and the square root of 1/4 is the same thing as the square root of 1 divided by the square root of 4. Square root of 1 is 1, and the square root of 4 is 2. And that's how we find x is equal to 1/2. And that concludes this video.